All right, so today we're going to be taking a deep dive into a really fascinating research paper.
Okay.
It's called Efficient Diffusion Transformer Policies
Yeah.
with Mixture of Expert Denoisers for Multitask Learning. Quite a mouthful.
Yeah, it is.
But essentially what it's all about is making robots smarter and more efficient,
Right.
especially when it comes to them learning by mimicking us humans.
Yeah, that's right. We're talking about diffusion policies for imitation learning.
Okay.
Um, and these have shown a lot of promise,
Yeah.
but scaling them up to handle like more and more complex tasks without needing a supercomputer.
Right.
That's always been the challenge.
Yeah, what's the special thing about this paper? What's the secret sauce that they've come up with here?
Well, they've introduced something called MODE.
Okay.
It stands for a mixture of denoising experts. And it's kind of like
Okay.
instead of having one generalist who's trying to do everything, they have a team of specialists.
Okay. I'm intrigued.
So
Break it down for me. How does this mixture of experts thing actually work?
So imagine you're trying to teach a robot to make a perfect cup of coffee.
Huh.
So rather than having one neural network, try to master every single step from, grinding the beans to brewing to maybe even the latte art.
Right.
Mode divides the task into smaller specialized chunks.
Okay.
So you have one expert for grinding the beans,
Got it.
another expert for brewing,
Makes sense.
maybe even a separate expert for that latte art.
So it's all about delegation and specialization, like a well-oiled kitchen crew.
Exactly. And that's what makes the learning process so much more efficient.
Okay.
But there's even more to it than that.
Oh, there's more. I'm all ears.
So Mode doesn't just randomly assign tasks to these different experts.
Okay.
It uses something called noise-conditioned routing.
Okay.
And this dynamically determines which expert is best suited
Right.
for the current stage of the learning process.
Hmm.
So if you remember, diffusion policies start with a really noisy random output.
Yeah.
They gradually refine it over time. And that level of noise in the data actually acts as a signal to Mode,
Okay.
guiding it to the right expert for that particular step.
So the system is constantly analyzing the data and deciding, okay, at this level of refinement, we need the brewing expert to step in.
Yeah.
It's pretty fascinating how they built that logic into the model.
And they have another kind of efficiency hack that they've incorporated as well.
Okay.
And it's called expert caching.
Right.
You can think of it like meal prepping for a busy week.
Right.
So Mode can actually pre-compute and store the results of certain expert calculations.
Right.
And that saves time and resources later on when the robot has to actually perform the task.
So not only do they have these specialized experts,
Yeah.
but the experts are super prepared and organized as well.
Exactly.
No wonder this mode system is getting such impressive results. What kind of performance are we talking about here?
So they've actually tested Mode on 134 different robotics tasks
Wow.
across 4 really challenging benchmarks,
Okay.
including Calvin and Libero. And Mode is not only beating previous diffusion policies,
Wow.
it's actually achieving state-of-the-art performance
Across the board.
across the board.
That's remarkable.
Yeah.
But how does this specialized approach handle tasks that it hasn't been explicitly trained for? Can it generalize its knowledge?
That's a great question. And what's really exciting is that Mode actually excels in zero-shot generalization.
Okay.
So you can kind of think of it like a chef
All right.
who can just improvise a new dish based on the ingredients that they have available.
Makes sense.
And they've specifically tested this in something called the Kelvin ABCE challenge.
Yeah, I read about that challenge. It's where they train the model in 3 different environments and then they throw it into a 4th one.
Exactly.
A completely new environment with a different layout and different textures. Quite a test.
Right. And Mode was able to take what it learned and adapt to that unseen environment.
Wow.
With a really impressive success rate.
That's huge. So not only is it efficient, but it's adaptable too. Are there any other benefits?
Yeah, absolutely. So Mode achieves all of these results while using significantly fewer FLOPs.
Okay.
Those are those floating point operations that measure the computational effort.
Right.
We're talking about a 90% reduction
Wow.
compared to standard diffusion transformers.
So it's like getting the same delicious coffee,
Exactly.
but using 90% less energy to brew it. That's a game changer.
It really is.
But let's be real, no system is perfect. Are there any limitations to this mode approach? What are the potential drawbacks that you see?
Well, it's true. They did observe that Mode's performance can be a little bit more variable
Okay.
compared to other models.
Right.
And there's also this phenomenon of expert collapse,
Okay.
where some experts end up being a little bit underutilized.
So it's like kitchen crew, where one expert ends up with all the work and the other one's twiddling their thumbs.
Exactly.
Makes sense that it'd be some optimization challenges in figuring out that expert workload.
Yeah, exactly. But these limitations are actually really valuable because they highlight areas for future research and improvement.
All right. So to recap, we've uncovered how this mode system uses these specialized experts.
Right.
And this really clever task allocation and even pre-computed calculations to achieve amazing results in robotic learning.
Yeah.
It's more efficient,
Right.
more adaptable, and just plain more impressive than previous models.
Yeah.
But what does this all really mean for the future of robotics? That's what I'm really interested in exploring next.
Yeah, I agree. Let's delve into the broader implications of this research.
All right.
And see where it might lead us.
Good.
Okay. Yeah, this research really does, paint this exciting picture of a future where robots can learn these complex tasks quickly and efficiently.
It's amazing to think we've gone from those like clunky pre-programmed robots
Right.
to these machines that can actually adapt and learn by watching us.
It is, and that's the beauty of imitation learning, right?
Yeah.
You can leverage the vast amount of data that we have from human demonstrations to teach robots new skills.
And mode seems to be taking that to a whole new level of efficiency.
Right.
But let's zoom out for a second. What are the broader implications here? How might this technology actually change the world?
Well, the possibilities are vast.
Yeah.
I mean, imagine robots seamlessly integrated into our lives.
Okay.
Helping with everyday tasks or even performing really complex medical procedures.
So we're talking robot assistants, robot surgeons,
Right.
maybe even robot chefs.
Potentially.
Yeah.
What's particularly exciting is that mode's ability to generalize to these unseen environments suggests that robots could handle like the dynamic, ever-changing nature of the real world.
Which is essential if they're going to be working alongside us in our messy, unpredictable human world.
Exactly.
Like traditional robots excel in these controlled settings.
Right.
But out in the real world, adaptability is key.
Precisely. It's like the difference between a chef who can only follow a recipe and one who can improvise based on whatever ingredients they have available.
Yeah, this adaptability opens up possibilities in personalized healthcare as well.
Yeah.
Imagine a robot that can learn to assist a patient with specific needs.
Yeah.
Adapting to their individual condition and environment.
Like having a personalized healthcare companion that learns and grows alongside you.
Yeah, incredible.
Yeah.
What about more high-stakes scenarios? Could this technology be applied in areas like disaster relief?
Absolutely. I mean, think about it. Robots trained on a variety of tasks could be deployed to these rapidly changing environments, providing crucial assistance after natural disasters.
This is starting to sound less like science fiction and more like a very near future.
Yeah, it really is. And the more we develop these technologies, the more we're going to discover applications we hadn't even considered before.
Yeah, it's almost like giving robots a set of building blocks and then watching them figure out how to construct entirely new solutions.
Exactly.
But as with any powerful tool, we need to consider the potential impact on society as well.
Oh, you're absolutely right. As robots become more sophisticated, we need to think very carefully about their role in our lives.
Right.
Both the positive and, the challenges that might arise.
One common concern is the potential for job displacement.
Right.
If robots can perform tasks that are currently done by humans, what happens to those workers?
It's a valid concern and one that we need to address proactively.
Yeah.
However, if we look at history, technological advancements have often led to new industries and job creation.
Right. So it's not necessarily about replacing humans.
Right.
But more about augmenting our abilities and freeing us up to focus on, more complex, creative, and meaningful work.
Exactly. So instead of spending our time on these repetitive tasks, we can focus on problem-solving, innovation, building relationships.
It's like having a superpowered teammate who can handle the heavy lifting.
Yeah.
Both literally and figuratively.
Indeed. And in many cases, robots can work alongside humans,
Right.
enhancing our capabilities, making us more efficient.
But as we develop these advanced robots, we also need to be mindful of their impact on our own psychology and how we interact with them.
You're right.
That's a fascinating aspect.
Yeah.
As robots become more lifelike and capable, could we start to develop emotional attachments to them? Could we even start seeing them as companions?
It's already happening. I mean, people form strong bonds with their pets,
Right.
which are far less sophisticated than the robots we're talking about.
Right.
So it's only natural to think that we might extend those feelings to robots capable of interacting on, intellectual and emotional levels.
But that raises these profound questions about the nature of our relationships with these machines.
Right.
Are they tools? Are they companions? Are they something else entirely?
And how do those relationships impact our own sense of self and our connections with other humans?
Yeah, it feels like we're entering uncharted territory here.
It is.
Where we need to be prepared for the social and psychological implications.
Yeah, absolutely. We need to be aware of both the positive and the potentially negative impacts.
Yeah.
For example, robots could provide companionship and support for individuals who are lonely or isolated.
They could even help us better understand ourselves and our emotions.
Absolutely.
But we also need to be mindful of these relationships potentially becoming unhealthy or harmful.
Yeah.
It's a complex topic we'll certainly be revisiting in future deep dives.
For sure.
We've covered a lot of ground today.
Yeah.
We've talked about the brilliance of mode,
Right.
the potential of advanced robotics,
Yeah.
and even the psychological impact of interacting with these machines.
Yeah.
But one question keeps lingering in my mind.
What's that?
Well, if this model can adapt so well to unseen environments,
Yeah.
could it potentially learn from human behavior in real time? Could it be constantly improving simply by observing us?
No, that is a thought-provoking question. It's
Right.
like the ultimate form of imitation learning, right? Robots that are continuously learning and evolving by watching us.
It's both exciting and a little daunting to imagine.
It is.
And this is precisely why we need to keep having these conversations.
I agree.
Exploring the ramifications of these technologies before they become widespread.
Right.
We need to be prepared, both technically and as a society,
Yeah.
for the future that's rapidly approaching.
Well said. This deep dive has been incredibly insightful.
It has.
It's really fascinating to see how, a single research paper can spark so many important questions.
Yeah, it really does feel like we've only just scratched the surface here.
We have, and that's the beauty of it. There's always more to uncover, more to explore, more to question.
Absolutely, as we wrap up our deep dive.
Right?
Let's leave our listener with something to ponder.
Okay.
Something that builds on what we've discussed, but takes it a step further.
I like that. What if we took mode's adaptability to the next level?
Yep.
What if instead of just generalizing to new environments, it could generalize to entirely new tasks?
Oh, I like where you're going with this. Instead of training a robot for a specific set of tasks,
Right.
we equip it with a foundation of skills, like grasping object manipulation navigation.
Precisely. And then leveraging mode's ability to learn and adapt.
Right.
The robot could combine and recombine those foundational skills
Okay.
to perform a near limitless range of new tasks.
So it's like giving the robot a toolbox of skills
Exactly.
and then letting it figure out how to use those tools in creative ways to solve new problems.
Exactly. Imagine a robot that can learn to assemble furniture just by watching a human do it.
Wow.
Or a robot that can learn to cook a new dish just by following a recipe.
This is taking us beyond simple imitation
Right.
and into the realm of true artificial intelligence.
Yeah.
Robots that can reason, problem solve, and even innovate.
It's a tantalizing possibility, and while we're not quite there yet,
No.
mode's research really does take us one step closer.
It's a really exciting time to be at the forefront of this field.
It is.
Who knows what incredible advancements await us?
I can't wait to find out. And I hope you, our listener, will join us on this journey of discovery
Yes.
as these technologies continue to evolve.
Absolutely. Keep those questions coming.
Yes.
Keep those minds open.
Right.
And keep diving deep into the world of knowledge.
Until next time.